So I thought it would be good to delve back into some history this Christmas. And if you remember back 11 years ago, long-term viewers of the channel, you'll remember that I built a set of computer-controlled Christmas lights, and there was lots of comments about I should have used an Arduino rather than a Raspberry Pi. But let's bring these up to date and do them in 2025 rather than 2014. So last decade, I built these and I used individual LEDs. They were white LEDs, and I had a wire for each of them that I then connected up to the Raspberry Pi. I didn't use an Arduino, much to the disgust of everyone in the comments, but hey, I use what's to hand. And it had one wire plus ground for every single LED that was there. It took me forever to build it. I used old network cable to create the wires, insulating tape in green so it blended into the Christmas tree, and so on. But I thought this year, I was putting my tree out at home, I thought, why don't I do something similar, but let's do it using 2025 technology. Actually, let's do it using technology that was around, if we're honest, in 2014 and do it properly. And I'm going to use individually addressable LEDs, like the ones flashing away behind me. And I thought it'd be fun to talk about these because actually the way they work, the way you program them, the way you send the data to them is quite fun and ties into some of the videos that people like Matt Godbolt have covered recently. So I think the place to start is to think about how these are connected up. When I built mine, I had, as I said, individual wires for each LED, which means I could turn them on and off individually. But if you look at these individually addressable LEDs, you'll see that there's actually only 3 wires used. Power, and in the ones I'm using, that's plus 5 volts. Ground, which is used to return the current from it. And you have a data pin, which goes to each LED. And the way these are connected up is really quite straightforward. You have your LED, and there's actually a driver chip which is driving these. We'll get into the detail of that a bit later on. And each individual LED has the power go into it, the data go into it, into the ground. And then out of that LED comes the power again, the data, which is then connected to the next LED. And then that's all connected to the next LED and so on until you've run out of LEDs. The ones I've got at home have got 50 on. I think there's 100 on the ones behind me. So there's immediately a difference between how they're connected up. With the ones I built, each one had its own wire, which made it easy to program. You could just set that to be on or off to turn the LED off. Here, we can ignore the power and the ground. We've only got one signal wire, which is connected to all the LEDs. So how are we managing to set them to be individual brightnesses or colors, and so on? How are we managing to get the data to control them? Well, perhaps the first place to start is to think about how we actually set the color. And the way the color is set on them is no different than the way you would set the color on a computer, on a pixel on the screen, in that we specify the red, green, and blue values. So if I want to make it red, then I would specify that using 24-bit color as FF0000 in hexadecimal. Full intensity red, between 0 and 255, that's FF in hex. No green, no blue. If I want to send it as green, there we are, then I'd set that as 00FF00, getting full intensity, and so on. And if I want to set it as blue, then, as you've guessed, 0000FF. So I specify a 24-bit number which specifies the color, and I can manipulate those bits to basically create any color that I want, from black light if I set everything to be 0, up to white light if I set everything to be FFFFF or 111111. So we need to send that number to each individual LED to set it to the color we want. But how do we send it? Well, we've only got one wire. We've said we've got each of these is going to take up 24 bits. We've only got one wire, so we can't send it on individual wires. We can't say, okay, send bit 0 of this on one wire, bit 1 on another, and so on. So we can't send it in parallel. What we're going to need to do is send it bit by bit by bit by bit. So we're going to send it serially. That's straightforward. We've talked about that on the channel before. But that would work for the first LED. But how do we then set a different value for the second one and then a different value for the third one? And this is where the first cool trick that these LEDs use, or rather the chip which drives them, these various ones, the ones I'm using at home are using the WS2811 chip, I think, in them, or a variation of it. the data sheet is there. So the way they work is really quite clever, because it works regardless of how many LEDs you have in your string of LEDs. You can have 1, you could have 50, you could have 100, you could have 2,000. The same approach would work. Once you understand how it works, you think, yeah, of course you do it like that. But actually, it's one of those ideas that seems too obvious at first. You might be thinking, oh, okay, we number each LED. This is LED 1, 2, 3, and then we send the number of the LED we turn on first, and then we send the color for it, and then we send the number of the next LED and the color. No, we don't do that, because we then need to have to specify, well, what number is each LED? How do we configure that? And so on. What happens is, when you turn the LEDs on, they will all start off, or what rather, when the chip is turned on, its outputs are all off. And as you send data to it, it reads the data that comes in serially, 100, 100, whatever it is you're sending, and it sets itself based on those numbers. So you send the first value. Let's say we want to set the first LED to be red. Then we're going to send a 1, and then another 1, and another 1, and another 1, and then another 1, and then another 1, and another 1, and another 1, and then 16 zeros, which I'm not going to write out. We send them across. That's sent the 24 bits that are needed for that LED. That LED then knows what color it is, so it turns itself to that color. But it now knows that it's received all the data it needs to specify that color. So what does it do if it receives any more data? Well, it just ignores it and passes it on to the next LED. So the first 24 bits come into the first LED here, blang, 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 da, 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 da. And then any more bits that come in get passed on, and the next LED does exactly the same things. It reads in the next 24 bits, and so on, and sets its color to whatever that value is. And then it starts ignoring the bits, and then the next one comes on. And this means, because it's so simple, that you can just connect the LEDs up in series, and it doesn't matter how many there are, as long as you know how many there are, you can just send the data, and they'll each turn on one after the other until you reach the end. And then if you continue sending more data, well, there's nothing there to receive it. It'll just fall off the end of the wire and get ignored, probably reflect back, but we'll ignore all the electrical engineering of what's going on there. And it will set the LEDs to that color. And it's just such a really simple idea. It's basically you've got to hand out a whole load of leaflets to people in a classroom. You pass them to the first one and say, take one and pass it along. And that's exactly what's happening with the LEDs here. The first LED's receiving its data, it sets itself to that value, and then it just passes on all the others as they come through to the next LED, and it does exactly the same thing, and then it does exactly the same thing. And so by the end of it, they've all set themselves to the color they need, and you've not had to worry about how to address them. You just know that the first thing I send will go to the first LED, the second thing I send will go to the second one, and then the third one and the fourth one. And so you can build these huge strings of LEDs and then just send a string of 1s and 0s down to it to set the color you want, and they will all turn on to the color that you want.
What happens if it misses a bit or something? Does everything just...
Yep, so it's a good question. I think if a bit's missed, it'll just get ignored, and so the data will get corrupted. I did actually have that when playing around with the software. You can get some of these LEDs which are just RGB, some of which are WRGB, and I set it to be, which is a white LED, I set it to be WRGB, and of course the bits then, you're sending 4 bytes of data rather than 3, and they all get sort of messed up. So the colours will just come out wrong. Reality is, I suspect that's unlikely to happen. You're dealing with relatively short lengths of cable, you're dealing with relatively low speed, so there's good time for the data to get up to the right voltage levels. And also we'll see in a second the way that it's transmitted makes it likely that there's not going to be interference. If the most likely cause of something to go wrong is that the wire is going to get cut, at which point half the LEDs won't come on because there's no way for it to pass the data on. But you just need to solder that wire back together and everything should hopefully then start working again. One of the other cool things that these LED driver chips do is the way that they actually send the data, send the 1s and the 0s over the data wire. They don't do what I did when I built these LEDs and just use 5 volts to represent on or 1 and 0 volts to represent 0 or off. Now what they do instead is that they actually transmit a continuously changing signal. It's a bit like Matt Godbolt was talking about when he was covering Ethernet. but they transmit it in a way so that they send ones and zeros differently. And there's a good reason for this, because you can actually send the data at two speeds to the LED driver chip that I was using. And so if you've got a long string of zeros, because you want to turn the light off, am I sending two sets at high speed to turn two LEDs off, or one set at low speed to turn one off? You can't tell. And you've got all the issues, of course, with interference and so on. So what they actually do, if we look at the data sheet, is really, really clever, is that they actually send the data in terms of a wave that always changes. So it always starts off by going high for a certain amount of time, and then it goes low for a certain amount of time, and then of course it'll go high again. So you've always got this signal which is constantly changing. You've already removed the problem of knowing where does each bit start and end, because the bits always go high, then they go low, then they go high, and then they go low again. But what's really clever is they actually send two different patterns of how it changes from high to low. If they want to send a zero, they send a short high voltage and a long pulse of low. That represents a zero. When they want to send a one, you send basically a long pulse at high voltage and a short pulse at low voltage. So you've always got this constantly changing signal, which is going high, low, high, low. But actually the time that it spends high compared to the time that it spends low specifies whether we're sending a zero or sending a one. So they always got the signals are changing, so they can always know where the bits start and end. And they can then look at the time it takes for the transition from high to low to work out whether they're sending a zero or sending a one, and they can distinguish between them. And again, you're not going to get a sudden spike on the wire which corrupts a bit, because you're not going to then have the right shaped pattern. The other really nice thing that this allows them to do is, we've talked about, well, you send the first 24 bits, that sends the first LED on, and you send the second 24 bits, that sends the third LED on. But once they're set, how do you do what's happening to the lights behind me, where they're constantly changing colour? The advantage of the approach they're using here is that they can send a different code, and what they do here is that they send the signal low for an extra long period of time, so there's no transition in it, and once they've detected that there's that extra long period of time, all the LEDs can then reset themselves, and then you can pass on the next colour value, and then you can set them all up again to turn them on and off.
So it's like a reset, is it? Would
Yeah,
you
it's a
send
reset.
that multiple times, or just sort of sit low for it?
So you have to sit low for, and here we are, here's the timing. Here we are, this is good. So if we were to send a zero, we have to send the high value for 0.5 microseconds, and then we send the low for 2 microseconds. Total of 2.5 microseconds, if my maths serves me. If we want to send the 1, then we send the high for 1.2 microseconds, and we send the low for 1.3 microseconds. Again, 2.5 microseconds, plus or minus 150 nanoseconds, but we've got enough time to specify each one, and they're sufficiently different that you could detect that they're a different length. I mean, if it was 1.2 and 1.3 and 1.3 and 1.2, then a bit of noise and you probably won't be able to tell the difference. By being sort of, what is it, almost 3 times shorter and twice as long, almost, roughly, I went with a rough value there, you can distinguish the times. For this, then you have to send this pulse for over 50 microseconds.
So is micro, so I'm missing my orders of magnitude, I'm guessing up a little bit. So micro, how many microseconds in a second? Is that 100? Or is
Million. So that's the cool thing. I just find it quite cool the way they're playing around with the timing to generate the different signals, because that saves things, and the way that you've got this really simple idea. It's almost like a physical manifestation of recursion, almost, in that you've got the first thing that does it, and then the next thing passes it on until eventually there's nothing else to take the case. The base case is that there's no other LED to pass this on to, and then you stop passing it on, and so on.
Okay, so question then. So back in the day, I remember growing up, you had Christmas lights that were serial, and if one of them failed, then the whole lot stopped
Yeah.
working. Would that be similar here?
I imagine that would be the case. If you actually look at the sort of circuit diagram that you've got here, you've got this chip, the WS2811 chip there, which has got the signal coming in and the signal coming out. If that chip fails, anything further down that is going to be dead. I mean, easy fix. You can just solder a wire across it and it will carry on. You've just got one less lead in this thing. But yeah, you would have the same problem. If the LEDs fail, then that wouldn't be an issue. But
If the chips fail.
if the chips fail, that would be, well, I suppose the LEDs could fail in a way that shorted things and it didn't work, but it's more likely that the chips are going to fail. But again, you're dealing with 5 volts on chips, and I still have computers from the 1980s that are running using far more complicated chips, so I suspect the issue is moot. One other cool thing about this, is if we haven't found enough cool things about our Christmas lights to talk about, is actually how they generate the different colours. So you can see from the diagram here that actually this chip doesn't drive one LED, it actually drives 3, one red, one green, one blue, and there are variations that can drive a white LED as well. That means that they can turn those LEDs on or off, so they can have red light or red and green light, which would give them yellow light, red, green and blue, which gives white, and so any combination of that. But the way that they actually get basically a grey level, a variation between them, is again by playing with the timing. So what they actually do, if you imagine the red LED being on, if it's just on continuously, it'll give out one brightness. But if we have it being on for a certain amount of time and then off for a certain amount of time, and we repeat that, it will flash on and off. And if we do that quickly enough, your eye won't perceive the flashing. What your eye will perceive is actually the LED at half brightness. And it uses what's called pulse width modulation, which is also used for things like certain CD players use it to play back audio and so on, to actually modify the brightness of each LED. And so by flicking these on and off very, very quickly, they can create the appearance of different colours. But actually, if you were to film them with a high-speed camera, you would see that actually they were either on or off for different amounts of time to get the effect that they were working for. There you are. Fun with Christmas lights and no AI involved. Well, except for the AI in fairy lights. But if the gap was there, then it'd be really quick to add things. I mean, if the gap was already there and we moved all this to this location, then we could add text here.
Do you mean if it was split in two?
If it's split in two, that's